Friends, so in today's question, the figure shown in block A constrained to slide along inclined plane of wedge B as shown in the figure. So block is attached with a string which passes through 3 ideal pulleys connected to wedge B. If wedge is pulled towards right with the acceleration A1, so in this case we are going to find out two things: find the acceleration of block with respect to the wedge, and find the acceleration of the block with respect to the ground. So it means it states that block or wedge B moves towards the right with the acceleration A1. And this wedge B is connected to block A using these 3 pulleys, and let us name the strings as 1 and 2, and we assume that block B moves towards right by distance x. Okay, so we see that if wedge B is pulled toward right by x, so it's quite obvious that block A will move in the upward direction this way. Okay, and block A is connected with wedge B using these 3 system pulleys, so the movement of block B will introduce some kind of slack in string 1 and 2. So you can say that this will result in the slack in strings 1 and 2, which will be of value, this will be also x and this will be x, so it means the total slack which will be introduced in strings 1 and 2 will be 2x. This will result in the slack in the strings 1 and 2 of each as x. Thus the block A will move up the inclined plane by 2x, and it is given that the acceleration of block B is A1, or we can say acceleration of wedge B the acceleration of wedge B is equal to A1. Then we can say the acceleration of this will be moving by 2x. Okay, so we can say that acceleration of, therefore the acceleration of block A will be equal to twice A1. So this completes our first part. Okay, so we can say that therefore thus the acceleration of the block with respect to wedge, thus the acceleration of block A with respect to wedge B will be equal to twice A. So this completes our part A. In part B, we are supposed to find out the acceleration of the block with respect to ground. So part B, and this was our part A. So part B, we can use the horizontal and the vertical component. So it is given that it is moving E1 in this direction with the angle of theta, and block A is moving upward by acceleration of 2A1. This acceleration can be divided into two components, horizontal as a vertical, so this angle will be theta. So we are going to 2A1 sine of theta, and this will be 2A1 cos of theta. This is our block A. So we can find out the net horizontal velocity, acceleration rather, and net vertical acceleration. Okay, so we can say that horizontal acceleration of block A with respect to ground will be given as twice A1 cos of theta minus A1. Okay, so we can also draw here axis. So this is our x-axis and this is our y-axis. So we get twice A1 and minus A1, and you can say the vertical velocity of block A with respect to ground, and let us call this as AX, and equation 1 we get vertical acceleration of block A with respect to ground. We can call this AY, and this will be equal to 2A1 sine of theta, and this equation is equation number 2. Thus we can say the net acceleration, therefore net acceleration of block A with respect to ground, let us call this as AA, and this will be equal to AX square plus AY square and its square root, substituting the value of AX and AY from equation 1 and 2. So we can write from equation 1 and equation 2 using AX and AY. Let us call this equation 3 in equation 3. So we get net acceleration ax is twice a1 cos of theta minus a1 whole square plus ay is twice a1 sine of theta whole square and its square root. We open the bracket, get this as 4a1 square cos theta square plus a1 square minus 4a1 square cos of theta plus this will be 4a1 square sine square theta. These two terms will be giving us cos square and sine square. So we get this as 4a1 square cos square theta plus sine square theta plus a1 square minus 4a1 square, sorry, here it has to be square root, and yeah, cos of theta 1 by 2. This will be giving us 1. We get this as 4a1 square plus a1 square minus 4a1 square cos square. Sorry. Sine square. Then write this as 4a1 square plus a1 square minus 4a1 square sine square theta. Let me do it again. There's some mistake I made it. So this will be 4a1 square plus a1 square minus 4a1 square cos of theta. No, it is correct. This will be 5. Taking a1 as common, so there is some mistake here. So if we combine 4a square, we get 4a1 square plus a1 square minus 4a1 square cos of theta. Taking a1 square as common, we get 5 minus 4 cos of theta whole raised to power 1 by 2. And now finally isolating it, we get that the acceleration of block A with respect to ground is given by a1 square root of 5 minus 4 cos of theta. Thank you.